So today I'll be explaining how I did this animation that I posted on my last video, which is a basic distance constraint chain, and I basically just adapted this code to TouchDesigner. This is a code done in JavaScript, and I just translate it to TouchDesigner. If you want to know more about how this technique works, I recommend this video. This guy explains it pretty well, how the code works, and I will link this and this page both in my description of this video. So I will start off by making the container square, and then I will split view and watch the output here. So I will create a render now in the camera. I will make the camera orthographic, bottom left, and one. I also need this to be square, so the same resolution as this container. So yeah, let's see the code actually. We'll start off by doing this just one point, and then the chain. So you just need really to follow this code. So we need a point and an anchor. The anchor I will use my mouse, so I can just access the mouse coordinates by using the panel chop, and then I will select inside U and inside V. Then I will create the point. We'll make it right in the middle. So let's render it just so we can see it. The line material. So there we have the point, and now we need to do these operations here. So we just really add a math mix, and then this will be our anchor. So the mouse positions, so X and Y. Then we really just need to follow the code. So point minus anchor minus anchor, it will give B. Then we need to normalize that. So B, and then multiply it by distance. So we also need to create that. So it will be the distance between our anchor and the mouse. So we can do it like this. We can actually just, let's create a constant that will have our distance. So this way we can change it later by more easily. So let's see, the normalize times distance. So p times distance, and then we add it again to the anchor. So p and anchor. So now I can see that something is happening. Let's actually render a circle. Just so we can see what's going on. So render geometry and line. And let's give it the same distance. So the distance will be our size. You can see that something is happening, but it's not updating. Like the point is always on the 0.5, so right in the middle. And we need to update that value, so we will just create a feedback and feed it right there. So now you can see that it's following. So that's good. So we got it working with 1 point following the anchor, and now what we want to do is to add more points. So I'll create it's written now here. Let's actually feed it this. So so to do that, to this thing, to add more points following each other, we will create a line. These values don't really matter, but I will change it anyway. So like to start off in the center. And this will have more points. So we can change the points here, or we can just create another constant. So let's create steps and say like 10 steps. So this will be how many points we have. You can either like name it steps or points, whatever. So now we have 10, we actually have 11 points, because 0 is to count, so I will just subtract 1. Now we have 10 points. So now instead of using this point, I will use this one that I created. And now what we need to do is, so the new anchor, instead of using the mouse, like for the anchor of 1 it will be 0, and the anchor of 2 will be 1, so on and so on. So the anchor of a point is the following point. So first of all, I will create a group because I want the first point to be my mouse coordinates. So I will create a group with the pattern 0, and then here I can add a map. So this group, so I need to update this group one. I will multiply it by 0 and give my mouse coordinates. So post add X and Y. So now I have some movement going on. Now to do that operation, to subtract the points from each other, we need to have another. So this will be our points, and now we need to create the anchors. So I will create so we need to offset this. So how you do that is by merging a new point to the existing line. Because now you can, so this will be our anchors, and this is the points. So we need to subtract from each point, and we can't really do that in a math mix. So we need to create another pop that will offset the points. So now the point 1 has the anchor, which has the coordinates of the point 0. So I hope you understand it. I don't know. So this will be our anchor, and this is the point. So okay, now merge this again. So now instead of using the anchor here, we will delete this and use this new value. So this is the in1p. It's the number one operator. So use 1p, and then we will add it back to the 1p. Let's start the feedback again, and as you can see, it's working. We just need to, instead of using this null here, we will use this one. So as you can see, it's working. Now we can if you want, we can also use a copy pop. This will be so like this. Now just deal with this translate, as you can see, and you can also, instead of using the same distance for every point, we can use a profile, like a curve. So instead of let's say it starts from like 0.1 to 0, and this will be our distance from each other, from each point. So we will use the steps here again. And now this is where we write, so just change the color. So I will put this curve with math mix, and instead of using distance, I will use the curve. So just set the feedback again, and you can also do that in the copy. So use a scale. For that, I will combine attributes. So the first one, the view, and the second one, the curve. And now curve. So to delete this, so back to one. As you can see now, you have different types of distance. You can change it however you want. So like this. One thing that I like to do is to ease the mouse movement, so use a leg. Now it's more smooth. And we can do that by, instead of using a circle, let's create points. Let's create 2 points, one that goes up and down. Let's render the points here. So as you can see, but we also need to rotate those points according to how the chain is moving, you know. And you can do that by using a slope. So let's convert this to a pop and use the slope chop. You will only need the x and y value, so 0 and 1. We will calculate the slope by using the previous and the next point. And then we need to convert this to degrees, so use the arctan function. The first input needs to be the y value, so select the y value and then the x value below. As you can see, this will give you degrees. So now we can convert this back to a pop and use P1 as like angle. We don't need this. So now you can also put it here. So use the attribute combined. So angle. Oh, there's a feedback loop. So let's use this now here, and then the angle. And now the rotation will use angle. It's saying that the rotate attribute should be 3 components. So just like we have 3 columns for the points, we need to have 3 columns for the angle, so it knows in which axis, it rotates on the x, y, or z, and in this case it will be z. So we will create an attribute here, count rotate, give it 3 columns, and now we have the angle here, and then we can use a math mix and say the angle will be rotate. Rotate here. So now this and we can do this here, and as you can see it now it rotates. So now we need to connect these points together. You can do that by using a primitive, say by pattern and line strip. And the reason it does this zigzag is because, let's see the point. It's because it goes from 0, 1, 2, 3, 4, 5. We need to connect it by like 1, 3, 5, 7. Now to do that, you can say move from move from 1 to 35. So 135. Skip. Okay, so I just found out that you actually need to be careful not to get the last point to be exactly 0, because that was giving me an error. So the steps, this needs to be integer and string. We need to go from 1 to 39. Let's say 1 to 39. So minus 1. So add a brackets and then 39 to 38. So 39 to 30. Eliminate this here. Then close the brackets. And then 38 to 0. So 38 to 0. Close the brackets. Then 0. So 0 to 1. So we forgot to add two, so just skip this and skip this filter. I mean, not here. Yeah. So here we go. Then there's probably a way to convert this to a surface on pop, but I don't know really how. So I'll just convert this back to a sub. So sub and render this with a constant. So like this. Then we can actually also smooth the snakes or blind smooth. That's probably the way to do it. Points. So like this. Smooth it and also maybe subdivide the before you add smooth, so now it's more smoother. So yeah, here you go. Have fun with it.